radicals instead as powers with fractional exponents, then if we have powers with the same base, we can actually do something with them. Okay? So if I look at the cube root of 2, I can write that as 2 to the 1/3 times the 5th root of 2 is times 2 to the 1/5. Okay? Well, this I can do something with because now I'm multiplying two powers with the same base. And when I multiply two powers with the same base, I add the exponents. So this is going to be 2 to the 1/3 plus 1/5. Okay, and then when we add fractions, what do we need to make sure of first? Yeah.
Their denominators, I think.
Correct.
So,
Common denominator.
Common denominator for this one would be, that I can think of, like off the top of my head, 15.
15, yeah. So one way that you can do this quickly, and a lot of people can do it in their head, this needs to be multiplied by 5 over 5. This needs to be multiplied by 3 over 3. Right? And then the denominators are both 15. You have to multiply it by 5 over 5, so actually you're only multiplying by 1. Right? And then we're going to get 2 to the 5 over 15 plus 3 over 15, and that's 2 to the 8 over 15. Okay? And then if you want to, you could put this back into radical form, right? So sometimes we would do that. And then 2 to the 8 is what? 256, I think, because it's 2 to the 4 times 2 to the 4. So this is the 15th root of 256. Okay? Now, I often get questions, well, which form do you want? Right? The answer is, honestly, I don't really care. But if this is a multiple choice question, let's say, and I said, which of the following is equivalent to that? You have to know that all of these mean the same thing. Okay? So that's really why I look at the different forms, so that you can understand that they're all equal to one another. But usually, we look at just this guy, I would say, more often than not. Okay? All right, let's look at this next one. So if we convert these into powers, the numerator is going to be 10 to the 1/3 over the denominator is 10 to the 1/9. Okay? Now, using exponent laws, there's something we can do here, because we're dividing two powers with the same base. Okay, so when we do that, what do we do with our exponents? Subtract, right? So this is going to be 10 to the 1/3 minus 1/9, right? And 1/3 is, common denominator there is 9. So essentially you have 3/9 minus 1/9, 10 to the 2/9, right? And again, if you can do that fraction operation stuff in your head, that's fine. Okay, so let's look at these three, and then I think I'm going to end it there. Well, I can't remember. Hold on. Oh, no, there's a little bit more that I'm going to do. Never mind, I forgot. Okay, we're almost there, though. Okay, so this guy, again, if I take each of these radicals and express them in exponential form, this guy is 2x to the 1/2 times x to the 1/3, right? And then I can express that as a single power, because all I need to do is add 1/2 and 1/3. Sometimes people like to do that off to the side, right? So I got to multiply this by 3 over 3, this by 2 over 2, and then I have 3/6 plus 2/6, and then that's 2x to the 5/6. Okay, and depending on, some people are really good at doing that sort of fraction operation in your head. right? And some people need to write more down, and both are perfectly fine. And I've seen students who are stronger in math that have to write more down than, so just do what you need to do to make sure that you're doing it correctly, okay? But you don't need to write down every little step. Okay, now this next one, we got radicals within radicals. So what I recommend people do when they see this, start from the inside, work your way out. So we're going to take this big guy and forget about that for now. And then let's look at the inside radical and express that as a power with a fractional exponent. So we're taking a square root. This is going to be a to the 3 over 2. Okay, now I'm taking the square root of something on the inside. So I can replace the radical with something to the 1/2. Okay, and then what was the radicand? It was a to the 3 over 2. So really, when I have these radicals within radicals, I'm basically taking power of a power. Okay, and now this is going to be what? 3 over 4? A to the 3 over 4.
That looked a lot more intimidating than it was.
Yeah. Okay. This last one, again, I'm not going to worry about this right now. I'm just going to work on this inside one and see if I can write that as a power with a fractional exponent. And I'm taking the 4th root of something. So 4th root of something is equivalent to raising it to the exponent 1/4. And then I just put this guy on the inside. Okay. Now at this point, there's some stuff I can do. Yes?
Could you just write it as x 5 over 4 and
Yep.
y 3 over 4?
Yeah, so you could do, there's 2 ways that you can do this, right? We have to distribute this quarter into each of these, and then we also have to distribute the 2/3 into each of those. You could also do it all at the same time, though, if you just multiply a quarter times 2/3. And then you just distribute that in, right? So this would be x to the 5 y cubed times, so this is going to be 2 over 12, right? Is that right? 2 over 12? Hold on.
Yeah, 2 over 12.
Which is 1/6, okay? So I can replace that one just distributing that in. So this becomes x to the 5 over 6, y to the 3 over 6, which is 1/2. Okay? So far, so good? Okay. Okay, so this is a very, very common style that you see in numeric response questions. And you will see some of those on your quiz tomorrow. I actually, by the way, this is just a side note, was planning to give you guys all written response for the quiz because I do think that it gives you better feedback. But for the first one, I decided to keep some multiple choice and numeric response in there, particularly the numeric response, because it's a very unique style of question, and you learn more as you do more and more of them. So I wanted you guys to have that before your first unit test. Okay, so this is a very common question that you might get in a numeric response. Okay. So here it is. Each radical can be expressed in the form ax to the n, where a and a is an element of the integers. That's poor math type. I'd make that better on a numeric response. So a is an integer, n is a rational number q. What is the value of a and n? Okay. So we need to basically get this into this format. essentially remove the radical symbol. Okay? So cube root of something is the same as raising it to 1/3. So this is something to the 1/3, and that something is 8x to the 5. Okay, now this is not quite in the right format because that 1/3 needs to be applied to each piece on the inside. So I'm going to distribute it. Remember, this is 8 to the 1. So I end up with 8 to the 1/3 x to the 5/3.
So,
Yes?
would 8 just become 2?
Yes, exactly. So then 8 to the 1/3, same as cube root of 8. This is 2x to the 5/3. So a equals 2, n equals 5/3. Okay? Now, what you might see on a numeric response question is, and it probably wouldn't be this specific fraction. Let's say n was 1/2 or something like that. I may say, what's the sum of a and n? Right? So if this was 1/2, the sum would be 2.5. That's what you enter into the numeric response box. Or sometimes I'll say, what's the product of a and n? If n is 1/2, 2 times 1/2 is 1. Right? So that's the kind of style. You got to get specific coefficients or exponents or whatnot. And then often, sometimes you're just asked for those values. Sometimes you're asked to do something with them, like add them or subtract them or multiply or divide. Okay? All right. I think I'm going to actually skip this one just in the interest of time because it's very similar to the ones that we did before. But just picking up on that a and n piece. And then let's just finish this guy, and then that'll be it. Okay? So the volume of a spherical shaped hot air balloon has a volume 18,432 pi meters cubed. What is the radius of the balloon? All right. Where are we going to start?
My brain did not comprehend words.
The volume of this spherical shaped hot air balloon has this volume. That's the volume of this balloon. What's the radius of the balloon? And we have a formula that relates volume to radius. Yes?
We have to rearrange the formula.
Okay, so have some of you guys taken science already? Okay, that's so funny because when I get a class that's already taken science, that's what they say. Rearrange the formulas so that you can isolate R, right? When I get a class usually in first semester and they haven't taken science, they're like, plug in 18,432 pi for V and then solve for R, right? You're going to get the same answer either way, but actually let's do it that way. I like that. So if we need to isolate R, okay, what is the second to last step that we're going to see? Like, what do we need to isolate before we can isolate R? Almost. We need to isolate R cubed before we isolate R. Because once we isolate R cubed, we can just take the cube root, right? So that's going to kind of be the goal. Now, when we have V equals, I'm leaving myself some room, 4/3 pi R cubed, okay? Basically what we're doing to R cubed right now is we're multiplying it by 4 pi, dividing by 3. So some people like to undo those in several steps. You can, though, undo them all in one step. Because what we need to do to undo that is divide by 4 pi and multiply by 3. Right? That undoes everything. And then the coefficient of R cubed is just 1. And of course, we need to do that on this side as well. Okay? And essentially, if you have a coefficient, you want that coefficient to be 1, you multiply by the reciprocal. Because a number times its reciprocal always equals 1. Right? Think about 2/3 times 3/2. That'll always equal 1. So if I multiply by the reciprocal, I can kind of do that in one step, right? So 3/3, that cancels. 4/4 cancels. Pi over pi cancels. and I have that r cubed equals volume times 3, or 3 times the volume. So maybe I'll rewrite this out, right? 3v over 4 pi equals r cubed. Okay, and now I can take the cube root to get r. The cube root of 3v over 4 pi equals r. And at this stage, I can sub in 18,432 pi for v. Three times 18,432 pi over 4. 4 pi rather, right? Now the pi's cancel, that's nice, because otherwise we'd have an irrational number. So pi over pi equals 1. And then this piece I could evaluate on my calculator. So 3 times 18,432 divided by 4 is 13,824. So cube root of 13,824. And I think, whoops, 824. I think this is a whole number. I think, let's see. Cube root of that. Whoops. Cube root of, I don't feel like typing that out again, by the way, so I'm going to use my answer button, which is right here. The answer, cube root of the answer, 24. Okay? Now, if it wasn't a whole number, you got to pay attention to the format that's wanted in the question. You may be asked to give an exact value, or you may be asked to express it as a radical and simplest form, or you may just be asked, what is the radius to the nearest hundredth? And then you would evaluate that on a calculator. Okay? But in this case, it's a nice whole number, so that's no ambiguity there. Okay, any questions? Okay, so the rest of this is practice. Okay, so what I would like to do at this point, I'm going to first turn off the recording. Let's do that. That's all done.